So absolute value function part 2. We're going over max and min and word problems. Yay, word problems. All right, so steps to find the max and min value. 1, you graph the function. 2, highlight the values on the given interval. 3, identify the minimum value. 4, identify the maximum value. Bam, that's it, finding the max and min. So here we have just the parent function, absolute value. So if I just have the parent function, I have a couple options here. I can solve by using the vertex and the slope. That's option B, remember from yesterday. Or I can graph it by creating a table. I'm going to just review both. So if you choose graph by table, we're going to call it. If you choose graph by table, remember you're going to choose points to the left and to the right of your vertex. So this is my parent function. I have no h, no k, so therefore my vertex is 0, 0. And points to the left and to the right would be -1, -2, 1, and 2. And the absolute value, because all it is going into the absolute value, is going to be 2, 1, 1, 2, right? So I'm going to graph that. So here, graph, tree, graph. All right, and I'm going to connect. I'm concentrating real hard to connect, y'all.
That's how we know you have OCD.
I'm not very good at drawing lines in this thing. All right, so that's graph by table, right? If you chose to graph by vertex and slope, then it's just go to the vertex. My slope is 1, rise 1, run 1, reverse it, rise 1, left 1, okay? Now it says on the interval from -4 to 2. So you're only going to look at the values between -4 and 2. So between -4 and 2. So values from -4 to +2. So you highlight what your interval is, interval highlighted, and now you should be able to identify what's the maximum and what's the minimum. So on this interval, my maximum is at -4 and is 4. So point -4, 4. That would be my maximum. My minimum is at 0. I'm sorry, x equals. Let me squeeze that in there. And is 0, because it's at 0, 0. Ta-da! Max and min. Now, yes, we started with the absolute value parent function, so graphing it was easy. But the process is what we're going over. So seeing this and looking at it, does it seem like it's a doable process?
Yes.
Graph, highlight, identify. That's all we're doing. Graph, highlight, identify. So here we're going to graph the absolute value of x minus 3, minus 1. So if we're using, I'm going to use the vertex and slope. So if I use the vertex and slope, my vertex, my h and my k, my vertex is at 3, -1, and my slope, since there's no number there, my a equals 1. So I'm going to go to 3, -1, and my slope is 1. So I'm going to rise 1, run 1, rise 1, run 1, rise, run, rise, rise. Okay. The other side is just symmetrical to this side. It's a reflection of these points. So instead of rising and going to the right, I'm going to rise and go to the left. I really don't need to go that far because it said 4 to 7, so I'm going to stop right here. Bam. Okay, my interval is 4 to 7, so I'm going to highlight from 4 to 7. I'm here at 4, I'm here at 7, and the space on the line is there. Okay, so now I've graphed, highlighted, and now I'm going to identify what's the max, what's the min. So my max is at x equals 7. Max is 3. My min is at x equals 4. The min is 0. Still feeling good about it?
Yep.
Perfect. All right, so here's your try. So if you have the graph f of x equals negative absolute value of x plus 1, and you analyze the maximum and the minimum on the interval -2 to 3, what would be your max and what would be your min? Okay, so when you graphed, did you guys use the vertex and the slope, or did you create a table? Possibly. I'm going to do vertex and slope. So here, I do not have a h, so therefore h equals 0. I do have a k, it's 1. So my vertex is 0, 1. My a equals -1, so that means my slope is going to be -1 over 1. Okay, so I'm going to go to 0, 1. And my slope is, I'm going to go down 1, right 1, down 1, right 1. I'm going to at least make sure I get to the needed interval. Down 1, right 1, down 1, right 1. Okay? And then I'm going to reflect it to the opposite. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And I'm going to connect the dots. Uh-oh. I tried to just do too much right there. I should just left it alone. Left well enough alone. I really want them to be friends. I feel like they should. Oh, erased too much. I didn't like this side anyway. All right. Okay, so have my graph, and my interval is -2 to 3. So I'm going to highlight from -2 to 3. So -2 to +3. Okay, I've highlighted, check. And now I'm going to identify my max and min. So on this interval, my max is at x equals 0, and the max is 1. My min is at x equals 3, and the min is -2. Boom. How do we do? We did good? Did bad?
Good.
Good? Okay. Okay, so putting it all together, word problems. A ride at an amusement park carries passengers along a vertical tower to give them a view of their surroundings. During a test run, a park employee records the height of the ride for 10 seconds. The function f of x equals the absolute value of x minus 5 plus 4 and 8/10 models the height of f of x of the ride in meters after x seconds. Graph the function and interpret the domain, range, intercept, symmetry, maximum, and minimum. Okay, so all that's coming together. They're telling us that we have a value of a ride, and it's 10 seconds. So if we were to look at this and create a table, so we have x, analyzing each point, and then we have our y. So we're going from 0 to 10 seconds, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're evaluating where is this ride after these number of seconds, because x represents our seconds. So I just begin filling it in. I can evaluate mentally or with the calculator, but we're gonna do it with the calculator. Now, when we put in 0, we're gonna notice something. And like, oh, it starts there. So if you want to go ahead and start filling the values, and then I'll ask y'all for the values, that'll be great. So as you're making this, I just want to ask, do you really need every value? Or can you kind of decide on a counting method and just utilize those said values? Do you want to think about that? Or are you using all of the values? So for me, I would probably just identify points. So I would do 0, of course. So the absolute value of 0 minus 5 plus 4 and 8/10 is going to give me 9 and 8/10. I would skip 1, go to 2. 2 minus 5 plus 4 and 8/10 equals 7 and 8/10, right? Skip, yeah. Obviously, I'm counting my 2s. I don't know if y'all caught on to that. 4 minus 5 plus 4 and 8/10. 4 minus 5 is 1. Absolute value of -1 is 1. 1 plus 4.8 is 5 and 8/10. I'm going to do 6. 6 minus 5 plus 4 and 8/10. And 6 minus 5 is 1. It's going to give me 5 and 8/10. Oh no, I noticed something. This is starting to repeat. So what does that tell me that 5 may be? 5 may be my maximum of some sort or a low point. So let me test 5. 5 minus 5 plus 4 and 8/10 equals 4 and 8/10. Okay, okay. Keep going with my patterns of 2s. I was doing 8. 8 minus 5 plus 4 and 8/10. That's going to give me 7/8. And then 10. 10 minus 5 plus 4 and 8/10. That gives me 9 and 8/10. Okay, so I've done that, filled in my table. And now I'm going to plot these points on my, oh my God. So at 0, I am at 9 and 8/10. I did not leave enough room for that, so we're going to guesstimate that year right here. At 2, we're at 7 and 8/10. Another guesstimation. At 4, we're at 5 and 8/10. At 5, we're at 4 and 8/10. How rude. I don't know why this does this, but when I put dots, for some reason, I'm like, no. You put too many dots, and then it takes it away. And then 6 and 5/8. Oh, I put it in the wrong spot. I was like, that's why it doesn't look right. Yeah. Oh no, it deleted it all. Okay, that's cool. I remember the numbers, I think. So we had 1 and 9/10. We had 2 and 9/8. Then we had 7 9/8, 5 and 8/8. Is it 8 or 9? 8. 5, 4, 6, 5, 8, and then 10 would be all the way off of here a little bit. 9, put 10. We're gonna make it work. All right. Connect them. And zoom. Okay. Whew. Close enough. I don't know what happened to my table. I think I accidentally hit the erase button. No bueno, but we saw it. So now we have what we need, and we're going to identify the domain, the range, intercepts, and symmetry of and the maximum and minimum. So the domain for this graph, like most real world situations, your domain, even though the parent function for absolute value is all real numbers, however, when you have a specific problem in a real world situation, it is not going to be all real numbers. It's going to be based on this problem. So based on this problem, the ride, oh, that's what I did, y'all. I completely switched. I was like, what happened to my numbers? Yay. This was in class, y'all were like, Miss Jones, maybe you should click backward. I had to read the problem and realize, Miss Jones, maybe you should click backward. And that was not very straight, but and then it disappeared from top. All right. It's good as gonna get. So the domain here, because I have specific starting stopping time for my seconds, well, my domain represents the seconds we're on the ride. And the ride only goes from 0 to 10 seconds, okay? The range here represents the height, how high it goes, right? The range represents the height. And so the highest that this ride goes, the lowest that the ride goes is 4 and 8/10. And then the highest that it goes is 9 and 8/10. So that's why it's a specific domain and range for the problem. Okay, and x-intercept, there are no x-intercepts. So we have no x-intercepts, but we do have a y-intercept. And our y-intercept is at 0 seconds, 9 and 8/10. And our y-intercept is, because we're never ground level, we are at 9 8/10. Ooh, sorry, I had to stretch. And then our max and our min. I'm going to write it on the graph. So our max and our min here, on our interval that we have, would be what? Oh, I skipped something. Symmetry. All right, symmetry. Axis of symmetry would be at x equals 5. And then our, what's left? Maximum and minimum. Our maximum height. Our max is 9 and 8. What are our units of measurement? Meters. Max, and that occurs at x equals 0 and 10. And our minimum height is 4 and 8/10 meters. And that occurs at x equals 5. And now we've put it all together, all of 2.3, and we've applied it to a real world situation. And that's that. If you guys do need to see another example, I do have another one. But if you if you feel pretty good about it, then that is it for today. Does anyone need me to walk through another example?
Nope.
Feel pretty good about it? Well, that is all. Please make sure that you